In this lesson, we are going to be talking about bias, variability, and sampling errors. To start, when we have bias in something, it's a consistent, repeated deviations of the sample statistic from the population parameter in the same direction. We can reduce bias by using random sampling, which we talked about in the last lesson. And a small bias means data will balance on a scale. Basically, that means that we'd have bias either way. We're not biased super on one side or the other, so it would be an unbalanced scale, if that makes sense. The next thing we'll talk about then is variability. So bias, I think, is something you're used to hearing. The next thing is variability. The variability describes how spread out the values are. So it doesn't mean necessarily by bias, it's how spread out they are. We can reduce variability by using a larger sample size, which we talked about yesterday a little bit. And a small variability means the data is clustered together. So if the data looks balanced in the way that it's spread out, that would be the bias. But the clusteredness and how close and spread out they are, that's the variability. So to kind of play around with that, we're going to look at these bullseyes. And we're going to see what the targets represent. So do they represent a large or small bias and a large or small variability? So bias here, if you were looking at bias, we want it spread out throughout the whole circle if it was a small bias. A large bias means it's going to be really close together, so it doesn't balance out where there's dots everywhere. So this right here, this circle, would be an example of a large bias. There's not dots equally distributed through all of this, so they can be considered balanced. That's what they mean by balanced. They're all together. So this is a large bias. And then how spread out are the dots? Well, the dots are all really close together, aren't they? They're not in the bullseye, but they're really close together. So we're going to say that that has a low variability. So this is a large bias, small variability. The second one then, see how the dots are more spread out and it would be a little more balanced on the target? That's going to be a small bias, but because they're spread out when we look at variability, that's going to be a large variability. So our bias, these balancing, how they are all over the place, that leads us to a small bias. But the fact that they're not clustered together leads us to a large variability. Number 3, you can see here we have all of our dots are right here, right? So with that, we have a large bias because it's definitely not balanced, is it? It's not going to, think of this as being like the balance point of a target, the center. It's not balanced. This would all be heavy on this spot right here, so it would be heavier over here. So that's why we have large bias. And then the dots are rather spread out, so we'd say large variability. They could be spread out more, so you could have a larger variability, but they aren't clustered together, so that's why we say large. And then the last one, notice the dots are all clustered together and they're all on the bullseye. So this is our example of a small bias, small variability. So that's just kind of one way to look at how you can see the data points and where they are on a scatter plot. You can decide if they have a lot of variability or not. If we want to have good sampling, we want to have a small bias and a small variability. That's our goal when we're doing a sample. Then we have some good sampling techniques. So here's some sampling that has both small bias and small variability. So good sampling techniques that have that. It says good sampling techniques includes the art of reducing all sources of error. So we want to try and make sure that anything that could cause us to have bias is going to be removed from our sampling or our study. So two types of errors. One error is a sampling error. There could be a couple options there. Random sampling errors, so that's when we're doing a simple random sample. They can be caused by chance. Let's say I pull 5 names out of a hat and they just all happen to be male. So I get no female input. That's a sampling error. I mean, we would hope that we'd have an equal or close to balanced amount of men and women that we survey, but that can be caused by chance. And that's what the margin of error covers. So when we calculate the margin of error, which is what we did in our last video, that's taking care of the random sampling errors. That's why we have a margin of error. We know that some errors are going to be caused by chance. It's just going to happen. There's no way we can perfectly sample everyone without doing a census, right? So there's one sampling error. Another one is undercoverage. Some groups left out or underrepresented. Let's say I decided to do a survey of our entire school. The best time to do that would be advisory, right? Because we have equal grade numbers in advisory, like they're spread out by grade, spread out by gender. So if I just pull a random sample of, let's say, 15 classrooms to survey in our school, and I pull the names out of a hat, what if I happen to do my survey on the day that the sophomores have a retreat, that sophomore retreat they always do? If I happen to pull it that day, I'm going to get sophomores left out of that group, right? Not on purpose. I did everything right, but I missed the sophomores because they were gone that day. That's an example of undercoverage. That group wouldn't be covered like they should be. Here are non-sampling errors. So this would be after you do your sampling, here's some things that can go wrong. Processing, so mistakes in mechanical tasks, such as I'm doing tally marks on who said yes and I miss a few. I mean, that's bound to happen, right? Response, so people, they give incorrect responses, such as when they give surveys in school on drug use, I'm assuming a lot of kids don't tell the truth because they're scared their teacher's going to look at that and they don't want to be known as using drugs. There's an example of where you'd lie on a survey. When they call me and ask me if I'm a racist on the phone for a telephone survey, I doubt many people would be like, oh yeah, I am a racist. Yep, that's who I am. You're not going to admit things like that, even though you might be. You tend to lie about things that you think are socially unacceptable, such as being a racist would be socially unacceptable, right? So there's an example of an incorrect response given. Someone would lie, or they maybe remember incorrectly. It could be an innocent lie. You didn't mean to lie, but you don't remember it properly, so then it's a bad response. The other one is non-response, and that's a big one that's used quite often. You call my house for a telephone survey, and guess what I see? I see that number come my caller ID, and I don't answer it. I think it is a solicitor or someone just calling me to ask me to donate to this cause, or maybe to buy some type of card they're selling, whatever it would be. I'm going to not answer that phone maybe, so that'd be non-response. It could be a survey that they want me to take because my telephone number got randomly drawn as taking a survey. So with non-response, there's no data obtained, and we can't contact those people. You can't contact them, or they refuse to participate. If they call and say, can we take 5 minutes to take a survey, people will often say, no, I don't have time for that, and hang up. This is the most serious error because it causes bias. For example, people who have caller ID can tell that that's a number not coming from Hutchinson maybe, and they would choose not to answer it, where people who don't have caller ID do. And maybe there's a difference between people who have caller ID and don't. People who have cell phones have non-response maybe because they don't answer those numbers also. So there's lots of ways that can happen, but this is our biggest deal. Non-response, people choosing not to participate, is our most serious error, and it causes a lot of bias. The last one is the wording of the questions. Wording creates bias. I often, when we are doing sampling in our classes, sometimes students will say, they'll pick a controversial topic and they'll say, let's think of something that would be controversial. Let's just go with dress code. We won't go too controversial. They'll say, do you think students should be allowed to have the freedom to choose what they want to wear, or do you think the school should dictate everything in our lives? There's an example of wording bias, right? By the way I said that, even the way I spoke it to you, you could tell which way I was leaning. I was thinking the school shouldn't control my dress code. And so you have to make sure your wording of your questions is extremely neutral. Any sense or idea you put in their heads is going to create bias, and you're going to have unreliable results based on that wording. So you have to be really careful to say, do you believe this or that? And you're just very generic. You don't add a lot of adjectives to your wording. You don't want to be very descriptive, because using adjectives and describing things gives you a certain sense. That's going to kind of throw people off. Ways to reduce non-response. So see, we said this was the biggest sense of error, right? Our biggest one is non-response. It causes the most bias. So here's how we can reduce that. One way is to train interviewers to keep people on the line longer. I know when people call me for interviews, if they're very friendly and they say, oh, you know what, I'm just going to take a couple minutes of your time, I really appreciate it, I tend to say sure. If they're kind of boring in their voice and be like, yeah, you want to take a survey, I might be like, nah, I'm not taking time for this person. So training people on different techniques that will keep people on the phone longer is a useful tool. Number 2 is to send letters in advance. And I've had this happen to me at my house. I get a letter saying, in a week or so, you're going to get a phone call from whatever the company is. We're going to ask you to take a consumer survey. We'd love if you'd be willing to participate, or something like that. And so I expect that call to be coming. So when it comes, I'm not, oh my gosh, I don't want to do this right now. I think, no, they took the time to send me a letter. Maybe I'll take this survey. I, of course, as a stats teacher, always take these surveys because I'm a freak about it. But let's say I didn't. And then number 3 is to call back over time. So if I keep seeing this number pop up in my caller ID, It doesn't stop. I might finally answer it and be like, I want to get these people off my back. And so you almost annoy them into taking the survey. So those are all 3 ways we can reduce non-response. Here are 2 ways to offset errors due to non-response. One is to substitute with other people. If I group people by, let's say, age and gender, and I have someone who's not answering the phone, I would just randomly select someone else from that gender or an age group so that I can decide, it's a similar person, so I'm not swaying the results too much, and then I just randomly select someone else because I'm not getting anywhere with that person that I'm keep calling. And number 2 is weight responses. We could weight the responses based on, like, if I only get 50 people in one group and 25 in the other, I'll weight them and kind of count them as double, or find a formula that works out where I can average them out and make it work. I don't want you to think that the only way that we do this is phone calls, but that is a common way that you'd know of in your household, so that's why I'm using it. There are mail-in surveys, there are all kinds of other things you can do with this, so it's not just phone calls that work. So now, the last thing is going to be 8 questions you ask before you believe a poll. So this is actually really crucial for us because one of the reasons we study statistics is when you're watching things on the presidential election, on new medical data coming out on the news, wherever you're watching it, people will try to sway you one way or the other. You could have the same poll and have 2 totally different outcomes based on the person who's giving it. So before we believe a poll that we watch on TV or read in a magazine or hear on the news, whatever it would be, these are the questions you should ask yourself before you decide if you should believe it or not. First of all, who conducted the survey? If the school district conducts a survey on how great we are, and we tell everyone in the community that Hutchinson Public Schools is the best in the whole state of Minnesota, in the country for that matter, our survey results prove it. If I'm the one who actually conducted the survey as an employee of the school district, you probably wouldn't believe me, right? A lot of times they'll say an independent surveyor, or they'll have someone outside their community, do the surveys, and that leads you more to believe them because I have a lot to gain by having people think our schools are good. Maybe I have a raise attached to it or something. And if our schools get a good recommendation, I make more money. Well, then I'm going to probably sway those results, right? I mean, you'd hope you wouldn't be dishonest, but maybe I'm going to interpret them differently. You want someone who has nothing to gain by this poll, a total neutral party. Number 2 is what was the population. If we say that all Hutchinson High School students absolutely love accelerated math, but I only surveyed my AP Stats students who don't even do accelerated math, that's not good population, right? I can't say that about the whole high school. So I have to say who was the population surveyed. If we only surveyed top math kids, maybe they all do think Excel math is great. We need to survey a random group of math students to really get good results. That kind of goes along with number 3, how was the sample chosen? Besides where the sample came from, we also want to know, did they just do a convenience survey? Did they just ask their friends, hey, do you guys like accelerated math? Maybe I made it a bonus point on my test. Do you like accelerated math, yes or no? And everyone thinks they're only going to get the point if they say yes. So how that sample was chosen is important because you want to know how much bias is in there. Number 4 is how large was the sample. We know, since we've been studying this, that the larger the sample, the better our results, right? So we want, if they only sampled 5 people, and they're talking about who's going to win the presidential election, I'm not going to believe that. And then what was the response rate? This is one that we might not understand, but the reason they do this is, let's say I tried to contact 5,000 people and I only got 200 to answer. That's a low response rate. Not many people participated in my survey, so I maybe wouldn't believe it as much. Number 6, how were subjects contacted? If I went door to door, or I called phones, or I didn't include cell phones, how did I contact these subjects? Was it a mail-in poll? So I went on the website and I said, hey, if you have an opinion on this, email me. And then everyone emailed me who really cared about it. We know that's biased because the people who didn't care so much didn't get surveyed. Number 7, when was the survey conducted? I could tell you great results of a survey from 20 years ago. And if I pretend to apply it to today, you might believe me. And so if that's a 20-year-old survey, that's old data, right? So you want to make sure it's current data. When was it done? The presidential election, they're not going to use results from the previous February. Those polls should be coming out in November, right before the election. And then what were the exact questions? That's to look at the wording bias and make sure that they didn't word it in a way that makes them choose one way or the other. So those are something you're going to have to use, and you're going to have to know some of those for your test, so make sure you kind of look those over and pay attention to them. Hopefully all of that made a little bit of sense for you today. If you have any questions, make sure you let me know tomorrow.